Um, Number one, give all asymptotes and holes. This is something that definitely I would add on my index card here. The rules are from the chapter where we graphed polynomials. So you might want to go back and check that little box with the rules. But asymptotes and holes, the vertical asymptotes has to do with where the denominator equals 0. And generally you want to factor this out. X squared plus 6x plus 8 factors into x plus 4 and x plus 2. And why that's important is because you can see that negative 4 or negative 2 are going to give you 0 on the bottom of a fraction, and that's definitely bad news. All right, but something weird happens when the thing cancels out. So you also, in this case, are going to need to factor the top. So the top's going to factor into 2x and x. I need numbers to multiply to 2, and they don't add up to 5 until I multiply. So I'm going to put the 2 over here because that's the one that gets multiplied by 2. I'm going to put a 1 right here. And so I factor the top, I factor the bottom, and we notice that the x plus 2 cancels out. And so that makes this negative 2 not a vertical asymptote, but a hole. So the one that does not cancel out, you're going to have a vertical asymptote at x equals negative 4. But the one that does cancel out is going to be a hole. So a hole at negative 2 comma something. And what that something is you look at the fraction where you canceled stuff out, except you look at what's not canceled out. And if you reduce this, it reduces down to 2x plus 1 over x plus 4. And so what you do is plug in that negative 2 and see what happens, see what you get. So if I plug in negative 2 for x, that's going to be negative 4 plus 1 over negative 2 plus 4. That's negative 3 over 2, negative 3 over 2. There is a hole at the point negative 2 comma negative 3 over 2. The horizontal asymptote is the one that I think you really need to look back at, because the horizontal asymptote has to do with the degree of the top and the degree of the bottom. So in this case, the degree of the top equals the degree of the bottom. 2 equals 2. So in that case, when that happens, what you have to do is divide the leading coefficient of the top by the leading coefficient of the bottom. There is going to be a horizontal asymptote at y equals 2, or 2 over 1. Not very many people are just going to remember that from 3 months ago. So that's definitely something you want to go back and look at. So then if I look at part B, I want to factor the bottom so I can see what makes 0 on the bottom of a fraction. Those numbers are bad news. Negative 2 and 2 are bad news. Nothing cancels out. And so what that means is they're both vertical asymptotes. This graph actually has 2 vertical asymptotes, x equal negative 2 and x equals positive 2. As for the horizontal asymptote, you look at the degree of the top. The degree of the top is 1 and the degree of the bottom is 2. So top is less than bottom, like that. 1 is less than 2. When that happens, when the top is less than bottom, then there's going to be a horizontal asymptote at 0. And so that's kind of the easy one, I suppose, because you don't have to do any dividing, but it's not necessarily easy to remember. So definitely go back and look at those asymptote rules. Add that to your index card. Logarithms. I think the most important thing you can remember about a logarithm is that a logarithm is equal to an exponent. So in this problem, you wouldn't be able to plug this into a calculator, but if you understand that we've got a base x and an exponent 3, maybe that makes it easier. Something to the third power is 81. Does that work out even? I don't think that works out nice. This is probably a bad question. in order to solve that, you'd have to take the cube root of 81. I'm not going to do that to you, okay? I would think a better question to ask on a final exam would be if that's a 4. So the exponent is 4. And think about what number to the 4th power is equal to 81. That's a much better question. You could say the 4th root is 3. 3 to the 4th power. 3 to the 4th power is 81. X equals 3. I like that question better. So then the next one, I could do the same thing. 3 to the x equals 10, but I don't need to in this case. When you've got log base 3 of 10, when you've got log number, you can type that in on your calculator. So some of you have calculators where it will just type it in. Most of us have to use the change of base formula. Log 10 over log 3. 2.096. X is about 2.096. Next one, log base 2 of x equals 5. Log base 2 of x equals 5. So that one, base 2, exponent 5 equals x. We can do that in our head. We don't need a calculator. 2 to the 5th is 32. X equals 32. Yeah, because I changed the problem. When it was a 3, it was not gonna work out nice. I mean, you can still do the problem, but it turned into a really gross number. But yes, I changed this to a 4, and so yes, this would be a 4. X to the 4th power equals 81. Well, it's posted on my Schoology page, so you can see it there. Number 3, right, as a single logarithm. So we definitely need to know how to do this. I know that the minus is going to change to division. I know that this 3 is going to go back and be an exponent. This 2, same thing, going to go back and be an exponent. So if you write it as a single log, base t, we're going to have p to the 3rd on the top divided by, and you're going to have s to the 5th to the 2nd. So you're probably not going to see it written like that. You multiply those two exponents, that's going to be s to the 10th is what that's going to end up looking like. So then the next one, this 1/2 is going to go back here and be an exponent. And this 2 right here going to go back here. And so it's going to be divided by, because it's minus. And that's going to be y to the 6th power, because it's y to the 3rd to the 2nd. Multiply. And write it as a single log. We're looking at log base 5 of that. Now, I'm going to tell you something is on the final. It doesn't quite match up with this, but it is the same thing. You need to understand that x to the 1/2 is the same thing as the square root of x. And so they're going to write it on the test in radical notation. And so the answer is going to look more like log base 5 of square root of x over y to the 6th power. So be ready for that. If I gave you a problem that said, or you know, if you're looking at x to the 1/3, that's the cube root of x. If I said the 4th root of x, it might be useful to you to think of it as x to the 1/4 power, but something like that is definitely on there. Solving log equations. All right, so in order to solve log equations, we're going to have to combine the logs. So combine the logs. I know that log plus log I can change to log of the multiplication problem. So log base 4 of, you just multiply those two arguments. Change your log plus log into log of a product equals 1. And so I'm going to multiply this out. That's x squared plus 5x plus 5x plus 25. That's x squared plus 10x plus 25. And what people mess up on this problem is we haven't done anything with the log yet. You still have a logarithm at this point. Log base 4 of that product equals 1. We want to get out of our log, and so the inverse operation, what cancels out a log base 4, is a base 4. And so I would do a base 4 on both sides, and that ends up giving me x squared plus 10x plus 25 equals 4 to the first power is 4. Now I've got something that I've dealt with a lot. You want to subtract this over, subtract the 4, you're going to have x squared plus 10x plus 21 equals 0. You should be able to solve this equation either by factoring or quadratic formula. I think factoring will work nicely here. Two numbers will multiply to 21 and add up to 10, 7, and 3. So finding the zeros, we would have -7 and -3, okay? But you have to remember, on a log equation, you have to check the domain. And what I mean by that is this has to be bigger than 0. X plus 5 is bigger than 0. So subtracting this over, x has to be bigger than -5. That's the domain. If you graphed it, the only thing on the graph is going to be bigger than -5. And so since this number is not bigger than -5, we would cross it off. It's not going to work. -3 is the one and only answer to this equation. So then on the next one, I would do the same thing. Start off by combining your logs. Log base 3 of 2x equals log base 3 of, go ahead and multiply, 4x minus 40. But then on this problem, what makes it kind of nice is when you've got log equals log, when you do your base 3 on both sides, it just cancels out, leaving me just 2x equals 4x minus 40. So if you subtract this over and divide by -2, x equals 20, maybe. We have to check it out though, all right? 2x has to be bigger than 0, so divide by 2, that means x has to be bigger than 0. All right, so that's good. And x minus 10 has to be bigger than 0, so add 10, x has to be bigger than 10. Yeah, I'm good. I'm good in both cases, so that is my answer, x equals 20.